Hello everyone, welcome to the channel Academy of Fine Learning. In this tutorial, we'll learn about the Java data types, Java typecasting. We'll learn about the different Java typecasting techniques and we'll familiarize with the typecasting in Java. This is the first objective of this video, and the second outcome of the video that we'll achieve after watching the video is to executing Java programs on typecasting examples. We'll see with many programs you will see which will use different sort of the uh, techniques of typecasting in Java, and also we'll get the notes, whatever the programs will execute and whatever the theory we'll learn from this particular tutorial, we'll get the link of this note so you can learn later. You can get the programs without typing from your site and watching the video. You can get the Word file, and using the Word file or PDF file you can get the things done at your computer. So that's the best benefit you can obtain from this particular video. You can get the notes also. So let's start. So first we'll go to this notes. This is the note for typecasting. This note you'll get. So what is the typecasting in Java? Typecasting is nothing but changing the type of one particular data type to another data type. This is the key. This is the key concept. Changing the particular data type variable's value from a single data type to another data type. For example, from float to integer or from integer to float. That's the typecasting concept. There are two types of the typecasting in Java. The first type is widening, that is typecasting, changing of a particular smaller sized variable's value to another larger sized data type's value. For example, from integer, if we convert a value to float, it becomes widening typecasting. So these widening typecastings are done automatically by the Java compiler. Or you no need to do anything, any new code to add. Or as a programmer, you don't need to add any new line of code or new syntax, nothing. Automatically it will be done by the Java compiler. So what is Oidening conversion? It takes place when two data types are automatically converted. It can only happen when two data types are compatible. So if you think that an object will be converted to an integer, then it's wrong. Object is a different type of a data type, and suppose a string is a different type of the data type, and integer is a different type of data type. So they cannot have any kind of conversion between them. But yes, an integer can be converted to a short or a byte or a long or a float or a double data type because they are compatible among them. They share the similar values. That is the first point to be noted for automatic type conversion. A point to be noted over here is that the automatic type conversion in Java is also known as the implicit typecasting. Both are same in meaning actually. The next point that you should supposed to know, that when you assign value of a smaller data type to a bigger data type, that time only automatic type conversion can happen. Otherwise, explicitly as a programmer, you have to specify some keyword. That keyword will do the opposite type of the type conversion, that is narrowing type conversion, which we'll be discussing on the next topic. Yes, so right now we are discussing about the widening type conversion. So a widening type conversion example is the flow is given over here. So byte occupies 1 byte of memory space, short occupies 2 bytes of memory space, int occupies 4 bytes of memory space, long occupies 8 bytes of the memory space, float occupied 16 bytes of memory space, and double the larger, the doubler. In this way, a byte can be automatically type converted to short, a short variable can be automatically type converted to integer, an integer will be automatically type converted to long, and so on. That is long to float and float to double. Let's see this particular claim which I'm making using a program. Let me see this particular program. Go to here. Let me paste this here. Yes, now we can see that from this particular example we can see an integer I variable which is holding the value 100 is converted to the long L. Now this long L variable is converted to the float F. So these things, here we are doing one type conversion and here we are doing another type conversion. So these two type conversions are automatic type conversion. So as you can see, no extra keyword is required, just the long keyword to specify that L is a long variable And to specify that f is a float variable, you have specified here float as usual. So no extra keyword is required for this short of the type conversion, because this type conversion happens automatically and it is performed by the Java compiler automatically. That's the benefit. So if you execute this particular program, what we'll see? We'll see that int value will be, this I value will be printed with the value 100. L will also get the value of 100 from I, and F will get the value of 100 from L. Although L is long, it will be assigned to float F. I is integer, it will be assigned to long L automatically without any user's involvement, any new code to be written. Nothing is required. But keep one thing in mind, float will be identified by a decimal value after a decimal point, and that will be in this case 0.0. We'll see that. Let me execute. Let's place execute. Yes, see this, the output you are getting. So in this particular line, the integer is converted automatically to long. This particular line, the long is converted automatically to float value, and we are printing here the float value, and here we are printing the L value. We are getting these values. Yes. Now we'll see about the narrowing or explicit conversion. So narrowing conversion happens just the opposite direction of the widening conversion, which you have just seen in the last example, and we have seen the program also. So when we try to convert a double value to a float value to a long value to an int value to a short value to a byte value, what we are doing actually, we are narrowing the data types, the larger data types value to a lower sized data type, correct? So in this particular case, what will happen? We have to specify a particular keyword to tell the Java compiler that we are going to convert from the larger to smaller. That is the narrowing conversion. So as we are writing some lines of extra code to tell the compiler that you are doing this narrowing conversion, it is also known as the explicit conversion. Yes. So now we'll see this. When it is useful, this is useful for incompatible data types when automatic conversion cannot be done. Here the target type specifies the desired type to convert the specified value to this particular range. We'll see this program, it's very easy. So if you execute this particular program, here we are converting from char, we are assigning to num. That's not possible, right? That's not possible. It will throw error. Yes, it will be throwing error. Yes, it cannot be launched. Error will be displayed over here because cannot convert from int to character. Yes. Now let me show. Sorry. Yes, I'll come to here. Now we'll see this. See this particular example. Here we'll see that how this explicit conversion actually happens. We paste. So this is the program. Look at this program carefully. A double value d with the value 100.04. This variable d stores the double value 100.04 is being assigned to a long. Now long is smaller than double, right? Long occupies smaller space than the double. So you are telling the compiler that we are changing this larger data type to this smaller data type. So this is the syntax for that. So this is the format. Target data type where we are converting in a smaller data type. Which data type we are converting to? So long, which is smaller than definitely d, and that variable name is d. So we have to pass this particular syntax. You have to add this particular syntax to let this programs work. So what we are seeing over here, d is now converted to long data type from double data type. It is done explicitly. You have to line a new line of code. That's why it becomes an explicit. So integer I is equals to integer L. So here also L is what? Long. Long is larger than integer. Long occupies double the memory space of the integer type. So again we are specifying the Java compiler that this long value is narrowed to integer. Now if we print this d, L and I will get these particular values. So let's execute. Double value is 100.04. When it is converted to int, it is losing the decimal values. Yes, some values are lost due to explicit type conversion. Generally, not always. As you can see in the next example, when we will convert from long to integer, it will not lose any value, because 100 can be stored in a long's memory space. The similar value can be stored in integer's memory space. Yes, 100, just 3 bits of memory space is sufficient to store 100, correct? So int consists of larger memory bits to store 100, so long is more than that, so it can store the value definitely. Yes, we'll see that in the next example, that if the value cannot store to this particular memory space, then we lose the major value. Next, we see here in this particular example that how type conversion can lose the original value. So we'll see in this particular example how typecasting can make you lose some value. So here byte is B, int is 257. So byte is having the range of 127. 127 is the maximum. From minus 128 to 127 is the range of value a byte variable can hold. Integer hold more than that definitely. So we have 257, so it will be stored in the variable I. 3323.142, that will be stored in the variable D, which is type double. Now we are converting from the integer to byte. So when you will convert this integer I to byte variable and store in the variable B, definitely it will lose some data. Why? Because I is having the modulus of 256. So 257 will be having the modulus of 256. So which value will remain? In B, the value will remain is 1. So 257 will not be displayed in the output screen. It will be displaying just 1. Similarly, from the conversion from double to byte, what will happen? This particular value 323.142 will be divided by 256, and the remainder will be stored in the value B. So we will be getting this particular value over here. So let me execute. So as you can see here, these values I is equals to 257 and B is equals to 1 is displayed from this particular line. And from this particular line, D is equals to, there is a double value is 323.142, and this B is displayed as 67 after this modulus operation. In this way, we can lose some original value in the type conversion. Now we'll see about the type promotion in expressions. Automatic type promotion. Automatic type conversion happens in mathematical expressions in a Java program. Yes. So what happens actually? Java automatically promotes each byte, short or character operator to int when evaluating to an expression. So character also works like integer. We'll see in the next program this. I'll execute in Eclipse again. If one operand is a long, float or double, the whole expression is promoted to long, float or double respectively. Suppose you are using character, short, byte and long. So if in the expression, in the mathematical expression, one variable is of type long, then the entire expression will be output the value into long. Similarly, if one expression is float, then the entire result will be displayed as float. Similarly, if one variable is double, the entire output will be displayed as double. So it is a very simple program to display these things to you. Let me see. Let us see this program. Yes. Let me hold the space, remove the space. So this is the program. Byte B is equals to 42, character is equals to A, S is equals to, that is a short type, 1024, here I is equals to 50,000, float F is equals to 5.67, double D is equals to 0.1234. Now we are writing this expression. This is a mathematical expression, correct? So F into B, it will be converted to a float because 1 is float here. So B is what? B is a byte. Byte will be taken as float. Here I is divided by C. C is what? A character. Character will be taken as this, its counterpart of integer value. So it will be divided by 50,000 by the C's, the counterpart value of the character C. Similarly, D is there, it's a double value 0.12 0.1234, that will be multiplied by s. What is the value of s? That is 1024. So after multiplying, it will be taken as double. So as now it will be outputted as double, the entire expression will be converted to double, and that's why you are using to store this double output to the double variable result. See this now, result has become 6 to 6 point whatever it is. After this mathematical expression executes, we'll get this particular value, and that is stored into the double variable result. Yes, automatically it is going to the result. Now let me do it in int. See, it's through a compile time error, because here there is a double 9 expression, so the entire thing has been converted to double. As there is a single variable of type double over here present, so the entire expression is converted to double. So I'll write here double, double. Yes, you must have to write double, otherwise it will be not resulting the entire thing. Yes, as you see, if I write here int, it will be throw an error because it has become a double. Then we have to write down here within the bracket int to change it to the integer. Again, explicit typecasting you have to do, otherwise we will take it into the double result. I hope that you understood this. Now we'll go to the next subtopic, explicit typecasting in expression. Now we'll see that how the thing which I was telling before, that will come to this point now. So that while evaluating expressions, the result is automatically updated to larger data, as you have seen in the last program, correct? But if you store the result in any smaller data type, like last time we take this thing as double, if you took to integer, it was showing error, right? Instead of double, if you write here, instead of this double in line number 12, if you write integer, just throwing some error, correct? So that thing is happening as it is smaller data type, correct? So we need to typecast that thing, and small example is better, I think. I have kept this example. Yes, here we'll write this program and now b is equals to, now sorry, it's not giving the correct thing. Write the larger one here, correct? Integer b is equals to 50. So 50 into 2 is what? 100. So 100 is taken as integer, correct now, because b is integer. This expression will output to int. So you'll write here what? Write here byte to convert it to byte data type, because b is of type, okay, b is of type byte. Now so we will write here byte. Here we'll write byte here, byte c. See this now, as it is, as c is of type the byte variable, now you are converting this particular integer expression to this byte expression, because you are specifying here that it is a byte 1. If you remove this byte, see this what happens, type mismatch, cannot convert from integer to byte. So it is taken as b into 2, as b is integer, the entire thing is taken as integer, and integer cannot be provided to a byte because byte is smaller data type than the integer. So tell the compiler that b into 2 is 100 and we are converting it to the byte. Next we can print into the output screen the value of byte. So this is the example of explicit typecasting of a Java expression like this, or any other expression. A big large expression is also fine, it will work in the same way. I hope that you have understood this. This particular note will be given to you as a guide for your further studies in Java, so that you can understand Java very well with hands-on examples and practical experiments. So hope that you have understood this. Please subscribe to my channel, like my videos, and comment in my videos. Thank you. Thank you very much.